So from an economic point of view, that makes good sense. From an evolutionary, from an ecological, and from an environmental point of view, I question the sensibility of that. The genetic homogeneity of hosts also facilitates spread. If you have a host species that is all genetically uniform or largely uniform, any pest that can penetrate host defenses will have a very easy time spreading through that population. If the host species is genetically diverse, it's much more difficult for a pest species to penetrate the host species and then spread rapidly. So there is absolutely genetic interaction between beetles and host trees. There are quite a few people working on that kind of issue, and it's because the beetles are actually attracted by chemical signals from the trees. The trees respond to the beetles by turning on certain genes, trying to produce pitch to fling out the beetles. There's a lovely set of genetic interactions there that are quite fascinating, and I won't get into them. But the pest species is turning over very rapidly in generations. Lots of variability being produced. All of those highly variable pest species can then continue to test the far more genetically uniform host species and make inroads. Here are some collateral issues. I told you that this is a complex story. Here are some of the collateral issues. As all these trees die, the hydrograph actually changes. The water balance system changes quite a bit in these forests. That's because when you lose the canopy, you actually get changes in snow accumulation. Snow will fall down in a canopy forest. It will shed around trees. It will be more dense in some areas, less dense in others. Without the canopy, you get a much more uniform distribution of snow. Not only that, but without the canopy, that snow melts much more quickly in the springtime, which means the rivers rise much more quickly and fall much more quickly, and there is a very much, I call it a flush type of runoff in the spring. Water leaves the land base very quickly. With the canopy there, the water will leave much more slowly, and it will be cooler water, because over the course of the summer, if the water is retained in the forest, it will flow more slowly, more uniformly into the major drainages. But it will also be cooler because the canopy itself, through evapotranspiration, maintains coolness at the forest floor. Without the canopy, you get this flush of water, and then what little water does go into the river systems during the course of the summer is much, much warmer. There's not the evaporative cooling, and there's direct sunshine coming in to warm that water. Stream flow rates, you get much greater flushing in the springtime, much lower volumes in the summertime. Has enormous implications for all kinds of organisms. You also get changes in air movement through these forests. And those changes have an enormous impact on the forest floor. Without the canopy, you get the wind coming through, you get drying of the forest floor, mosses, lichens, fungi, ferns are moisture dependent. They tend to disappear very quickly. Not only that, but you don't have the roots of trees drawing water out of the soil through evapotranspiration being lost, so the water table actually rises, demonstrably rises in these regions. So the water, without being drawn out by tree roots, comes up closer to the surface. Has enormous implications, again, particularly in areas where you're close to being a wetland. You actually have more extensive water. Biodiversity. Without the canopy, you have fewer lichens, you have fewer bird species, you have an enormous cascade of changes. Wildlife changes, water flows, fish species. I can't begin to tell you all of the changes that take place in this kind of context. And now think about the area that is impacted. The area that I showed you on those maps is all of southern Ontario, well into Quebec, all the way to Montreal at least. It's huge. It's absolutely huge. Here's some further collateral issues, getting to the human dimension of this. In that region, the communities are almost all forest dependent. There's a high level of economic dependency and employment dependency on the forest sector. I don't know how many of you heard today about yet more mill closures in the country. Abitibi-Bowater has announced today that closing 8 more mills permanently. Community of Dalhousie in New Brunswick is wondering, do they have a future? Well, in BC, those concerns are very much on everybody's mind, but in the meanwhile, while all this pine is dying, there's a bit of a gold rush, as people think of it there, second gold rush. There's enormous, enormous amounts of timber being harvested right now, flooding the market. The annual allowable cut, AAC, I wasn't aware this was going to be published, so I used some acronyms here, so my apologies. But AAC stands for Annual Allowable Cut. The provincial chief forester tells companies how much they can cut every year, and it's been enormously raised to take advantage, to salvage the value of that timber. But in the medium term and long term, there will be a shortfall in the availability of timber. So there's a huge increase right now, salvaging all of this wood, and then there's going to be an abrupt decline. And that abrupt decline is going to have tremendous economic consequences for those communities. The resource grows slowly, so the replenishment of trees back to an historic level of sustainable harvesting will be very, very slow. Communities will absolutely struggle, and some of those communities may in fact collapse entirely. This is a projection of the total volume of lodgepole pine that will be killed over time. That vertical line is at 2014. That's what I showed that projection out on the map. And by then, roughly 80% of all the pine in the province will be dead. And that means that in terms of harvestable value, the left-hand axis shows that about 850 million cubic meters of wood will be dead, gone, not available. I don't know how many of you can envision what a cubic meter of wood looks like. Well, it's not very different from this podium. Just imagine so many millions of cubic meters of wood being gone out of our system. And here is one of the great concerns about this. This shows the border between Alberta and British Columbia. The red area shows where the mountain pine beetle is currently infesting lodgepole pine. But you will see, I don't know if you can see this very clearly at the distance, but in the Fraser River Valley, going into Jasper Park, Jasper is the northern one of the 2 national parks there. There's a line of red dots. There's lodgepole pine throughout the valley bottoms. It's in fact Mount Robson Park, just adjacent to Jasper Park. And they've in fact, park managers have now burned off mountainsides of lodgepole pine to try to prevent the beetle from spreading into Alberta. Across the border in Alberta, lodgepole pine is replaced with jack pine, very closely related species. And just in the last 18 months, it's been discovered that the mountain pine beetle has now invaded jack pine in Alberta. And jack pine has a distribution that comes right across here, Ontario, right into the Maritimes, and even down into the southeastern United States. So the question is, will this epidemic spread to Alberta in a significant way, and then to the rest of Canada, TROC, the rest of Canada?